Example number 3, solving a problem using a sinusoidal function. The far north is called the land of the midnight sun for good reason. During the summer months in some locations, the sun can be visible for 24 hours a day. Whew. The number of hours of daylight in Iqaluit, Nunavut, can be represented by the function y equals 8.245 sine 0.0172 open bracket x minus 80.988 plus 12.585, where x is the day number in the year. Remember, y is the number of hours of sunlight. It's sometimes hard to remember that when you have a huge equation in front of you and lots of words. So, A, how many hours of daylight occur in Iqaluit on the shortest day of the year? What about the longest day of the year? So this one right here, we're talking about the range. What's the least and what's the most? In some years, June 21st is the longest day. Suppose that the sun were to set in Iqaluit at 11:01 p.m. on June 21st. At what time did the sun rise? Then the last one, what is the period of the sinusoidal function? Explain how the period relates to the context of this problem. So first things first, wouldn't it have been nice though if they started out with what's the amplitude? That's what's so great about applied. We will only ask you things that are like really important to the question. The amplitude, it would be interesting to think about what that amplitude could represent in this problem, but that's not what we're going to focus on. So, how many hours of daylight occur in Iqaluit on the shortest day of the year and the longest day? So remember, we're talking about range. So we're talking about our max, which is d minus a, and our min, which is, d plus a, and our min, which is d minus a. So our d in this scenario is going to be 12.585, and the a in this scenario, the amplitude, is going to be 8.245. So I'm going to say 12.585 plus 8.245, and this one's going to be 12.585 minus 8.245. So the max here is, the max here is going to be 20.830 hours. And the minimum here is going to be 4.340 hours. So on the longest day of the year, it's going to have 4.340 hours. And on the shortest and on the longest day of the year, you're going to have 20.830 hours of sunlight. How crazy is that? That's amazing. So in some years, June 21st is the longest day, so it has the most amount of sunlight. So we're going to be dealing with this one right here. So what time, so suppose that the sun were to set in Iqaluit at 11:01 p.m. on June 21st. What time did the sun rise? So we got to think about it. The number of hours of sunlight in that longest day will be 20.830 hours. So let's just do a fun little thing. So we have 20 hours and 0.830 hours. Okay, so let's convert this into minutes. So on the longest day, if it sets at 11:01, it means that the sun were to rise 20.830 hours previous. So we have 20 here. So this one right here, let's convert that into minutes. So 0.830 times 60, which is going to be 49.8 minutes. So that means that's 20 hours and let's just, for the sake of this, 50 minutes before 11:01 p.m. So I'm going to subtract 20 hours, and I'm going to take into consideration here. What I love to do in this situation is I really like to draw it out, because my dad calls it fence post theory. Like when you have two gaps, how many fence posts would you have? You would have 3. So sometimes those kind of questions trip me up. So I'm going to say 11:01. I'm going to go 12 hours before. So this is going to, so minus 12. This is going to be 11. This is p.m. This is going to be 11:01 a.m. So I'm going to go 11, and I'm going to go 8 more hours. So 11, 10, 9, 8, 7, 6, 5, 4, 3. So let me see. 1, 2, 3, 4, 5, 6, 7, 8. Good. So that is going to be 3:01 a.m. because this is going to be minus 8 hours. But now what I want to do is I want to subtract 50 minutes here. So that's going to be at 2:11 a.m. So that means that it will have rows at 2:11 a.m. That 2:11 a.m. previous. How crazy is that? The sun rises at 2:11 and then sets at 11:01. That's nuts. The last question is, what is the period of the sinusoidal function? Explain how the period relates to the context of the problem. Now, whenever it doesn't have specific degrees, we want to remember that this is going to be in radians. Unless it explicitly says degrees, we're going to assume radians. So that means that the period equals 2 pi over b. Let's just check to see what our b is here. And our b is going to be this value right here. So 0.0172. 0.0712. Oh, sorry, 172. And the period here is, just type it into your calculator. Just put this on pause. I want your mind to just be totally blown. Okay? Just do it. Pause it. Trust me. What did you notice that it is? How cool is this? It's 365.30 da. What does that represent? That represents how many days there are in a year. So that's one full cycle. How cool is that? Lots of exclamation marks there. What is with this 0.3 bit though? Let's think about it. Are there actually on average 365 days a year? No. We have leap years where we have an extra day. So really, on average, if you would take over 4 years, it would be 365. If you just did it mathematically like that, it would be 0.25. So 365 days plus a quarter of a day. And of course, that's not like we need to make it fit our human cycles. But there is actually an extra little bit of day there. So that is how that extra little bit can be accounted for by our leap year. So what I want you to do is page 558, numbers 5 to 9, 13, 14, 16, and 19. Have fun!